to present that for us. So let me go ahead and put this in slide view. All right, go ahead, Veronica, it's your show.
Hi, everyone. My name is Veronica Bratlin. I'm a graduate student at the WTSC lab, and I've been part of it for almost 2 years now. We can go to the next slide. So what type of research do we do at this lab? We're all familiar with wearable technology. Basically, these are sensors that are worn to track biometric data. The majority of us see them in the forms of smartwatches, but what is different about us is that we're exploring an area of the body that is less explored, which is the oral cavity, which is, I think, what really makes us unique. So what I'm going to focus on is on this trackpad that you see on the screen, which is the project that kind of got our lab started. We can go to the next one. So there is actually a communication bill of rights that states that everyone, despite disabilities, has the right to communicate and have access to assistive devices that facilitate communication. Current assistive devices that are used to interface with computers include brain implants, EEG cabs, EMGs, but these are often intrusive and require elaborate setups and often attract unwanted attention to the users, decreasing the rate of adaptation of these devices. We can go to the next slide now. So this is one of the reasons why we targeted the tongue as the medium of interaction. Because of its concealed location, we're able to develop discrete assistive devices. Another reason that we chose the tongue as the medium of interaction is that it is innervated by the hypoglossal nerve, which bypasses the spinal cord, and therefore the tongue retains its functionalities even after spinal cord injuries. We can go to the next slide. So if we play this video, this is actually a video of me demoing this device. We were featured on WGN. And what I'm doing is I'm wearing the retainer that contains the trackpad, and I'm swiping my tongue across the trackpad in order to control that cursor on the computer screen. I also had the opportunity to conduct a study in which 10 healthy subjects used this trackpad to complete functional tasks on their laptops. We're currently working on that we want to publish this work. We can go to the next slide. So this slide right here shows another application of this device, which is studying the tongue motion. There's a need for the quantification of deficits that affect the tongue's motion, which is something that our device is able to do. We've been able to quantify the tongue's position, velocity, and acceleration during movement, which is represented here by these two-dimensional histograms. We actually have conducted studies on healthy tongue motion and on pathology-specific tongue motion. We were able to go to Shirley Ryan and work with some patients that have speech ailments. So that was a super cool thing to experience. We can go to the next slide. And then for this, you gotta click multiple times. So these are some of the different projects in the lab that center around this trackpad. We can use it for tracking vital signs. We were able to disclose, we're working on a project right now, or some other of my lab mates are working on a project that decodes speech silently, which is super cool. We can use it for gaming, for controlling assistive devices, etc. We can move on to my last slide. So what will you learn at the WTSE lab? I think my favorite thing about working in this lab was that I got to experience building something from scratch and then applying it to the real world. I learned circuit design and fabrication. I learned how to develop my own user interface and make it work with my hardware. And then the final step was data collection and being able to create human experiments. And I got to work with a lot of people with different various backgrounds, such as speech pathologists and clinical staff. So I thought that was pretty cool. And this is some of the things that you will be able to learn if you join our lab. Yeah.